All right, let's take a look at our lesson on the law of sines. So we have practiced using trig ratios to find side lengths and angle measures of right triangles, and I've been very dramatic and clear that it only works for right triangles. But now we are going to learn about a few laws. The first is the law of sines, which shows the proportional relationship between angles and their opposite sides. And it can be used to find side lengths and angle measurements for any triangle. Okay, any triangle. So take a look at this triangle. We're going to use capitals A, B, and C to represent the angles and the vertex of each angle. So angle A, angle B, angle C. And then lowercase to represent the side opposite that angle. So side A is opposite angle A, side C is opposite angle C, and side B is opposite angle B. So given triangle ABC, the law of sines says sine of A over A is proportional to sine of B over B, which is proportional to sine of C over C. And yes, that is the law of sines. We can show the proportional relationship between angles and their opposite sides, using this to find side lengths and angle measurements for any triangle. So let's start with a very basic example. We are looking for x, and we can use the law of sines. So sine of 71 degrees over x, over x is equal to sine of 35 over 12. And then we can do cross products to solve for x. So 12 times sine of 71 is equal to x times sine of 35, and then divide by sine of 35 on both sides. So x is equal to 12 times sine of 71 over sine of 35. Put everything into your calculator, round to the nearest tenths, and you should get 19.8. So I want you to check how you do that in your calculator. Make sure you know how to do it correctly. You should get that answer. So I want you to go ahead and try 3, 5, and 7. And I'm going to give you answers right now so that you can double check your work. 3 is 17.9, sorry, 7. 3 is 17.9, 5 is 23, and 7, the answer is going to be 17.6. So try those 3 right now. Pause the video, try them, check your calculators, make sure you understand opposite, sine of A over A, sine of B over B, etc. See what you get before we move on. All right, hopefully you practice those 3 so that we could talk about using law of sines to find angle measures. Same exact thing, and we know when we're finding the angle, somewhere sine inverse is going to be involved. So let's look for x degrees. So let's set up using the law of sines. Sine of x over 9 is equal to sine of 77 over 14. Here is the x, and we are looking for x. So let's start isolating. So we're going to go ahead and multiply by, do our cross products. So let's write this as 14 sine of x is equal to 9 sine of 77. Okay, here is x. So let's divide by 14. I'm going to take my work over here. So sine of x is equal to 9 sine of 77 over 14. Move that 14 to the other side. I'm going to find this number now by putting that into my calculator. So multiply 9 by sine of 77, divide by 14, and you're going to get about we're going to take it to 4 decimal places just to get a more accurate approximation. So take that to 4 decimal places. We get sine of x is equal to 0.6264. So throw that in your calculator. And now we need x. So we're going to sine inverse on both sides. And sine inverse and sine regular cancel each other out to get sine inverse of 0.6264. Throw that into your calculator, and you should get rounded approximate 38.8 degrees. So we can use the law of sines to find a missing angle. There's just going to be that extra work of taking the inverse sine at the end. So just like in the last page, I want you to try 11 and 13. So 11 is going to be 49.9 degrees and 13 is going to be 59.1 degrees. So go ahead and try those now and see if you get the same answer.